you have to excuse all the welding activities going behind us. We got a guy welding in some rockers over there and somebody welding some aluminum over there, so the lights are going to be flickering quite a bit. Alright, so this is the master, okay? These masters tend to be fairly pricey, so we got to try to save this one if we can. We happen to have some very old honing tools that were initially designed to do something just like this, so we're going to attempt to use them to save this, okay? Now, with that said, I freed up the pedal from the actual master cylinder, and the master cylinder moves in just fine, but the minute you compress it, it locks up all four wheels. So that means the bleed back is not working. Now, odds are this is just a little bit of rust and debris that's in the way that needs to be cleaned out, and that's exactly what we're going to do. What's tricky about this is you would prefer to try to take the lines off of the master before you drop the master out, because it's held in place right now with those. But it's a very tight fit, and even with the best of brake line wrenches, it's a very daunting task. So we're going to ignore that part. What we're going to do is we're going to drop it down, because there's a bit of flex in how much lines you have there. So we're going to drop it down, and then we're going to take the brake lines off of it. And at that point, we're going to disassemble the master and see if we can't clean it up to get the bleed back to start working again. If that fails, then it's time to get this thing sent out and get it rebuilt. Yeah, we could buy new ones, but the new ones tend to not be nearly as good as the originals, and they are expensive. So it just makes good sense to rebuild it if you can. Okay, in order to get the master out, we really kind of need to alleviate the pressure off of the actual clutch fork. So we're going to pull the clutch mechanism, the linkage. We're going to pull it out. Now this is under a little bit of stress, so be careful if you have to do this. Like I said, it's under a little stress. Alright, so now with that said, I can move the actual clutch pedal out of the way and I gain access to the... There, just drop down just enough for us to go ahead and put our brake wrenches on. Alright, so we got the master out. It's over in the partial washer. We're going to clean it up and start opening up, see what we got. But as you know, brake fluid is pretty acidic, meaning it will burn through paint, it'll burn through a lot of things. So we're just going to let our transmission jack hold up the cup and let it drip into there for a while. Okay, so we got to flush it back out, no big deal. But on the flip side, at least we're having the opportunity, and hopefully we'll be able to save that master cylinder without having to send it out. What automatically qualifies as a potential save is because the primary O-rings that hold the piston in place aren't leaking. If you notice, that master cylinder was quite dry before we started disassembling it. So that tells me, from that point of view, if the insides are just a little gummed up, then we're good shape. But if it was leaking, it doesn't matter. It's time to get a rebuild kit, or at minimum, get a rebuild O-ring kit. But most likely we'd end up having to send it out to have the whole thing redone anyhow. So now we're going to go over the parts washer and see what we got. Alright, so fresh out of the parts washer, cleaned up pretty nice, but exterior doesn't mean anything. It's all about what's internal to it. But again, because the O-ring wasn't leaking, we find that to be a plus in trying to save this. Alright, and it's getting there, so I'm going to start tearing it apart. Okay, the retainer and everything looks to be in good shape, so I'm going to disassemble this, take the retainer off, and the whole assembly should come out. Okay, there is a spring load right down in there. You take some good needle noses and compress, and this whole thing disassembles. Okay, when a brake master starts to fail, it's usually because this O-ring right here starts to disintegrate. And it starts to leak around the boot. I'm gonna pour out some more sludge. So that's the primary top that compresses against the actual foot pedal. This is the rear one. This one's usually just as screwy as the front one. This one doesn't have any problems. It seems to be well intact, and when I wipe it away, I'm not getting any rubbery residue onto my rags. That tells me that it has not lost its elasticity, and it's not, you know, breaking down. So we're still in good shape. So now it's a matter of cleaning out the actual cylinder wall. Now this is a 22mm Aute master cylinder. So once I take the internal spring loads out, which is that right there, I'm going to flush out the inside of this in our parts washer. At that point in time, if I see any rusting or debris in there, it's time to hone that out, and I'll show you what that looks like. Okay, so this is the primary piston that's getting pushed, and it's pushing the fluid to and fro. This right here, this is how the fluid bleeds back. And all 6 of those bleed backs plugged. So odds are, if I just clean this up and reassemble this thing, it's going to be fine. We're not going to stop there because we're already here. We're going to go ahead and still clean up the actual master cylinder itself, because as that car has been sitting for 20 plus years, all that sediment has settled into that master cylinder, and that needs to be cleaned out really well. There's no reason not to do it at this point. We're already there, right? So odds are, most likely that's the culprit. You know, all those holes are plugged. So we very well may be in good shape. Now see, the natural instinct is when the brakes lock up like this and the master's not releasing, the natural instinct is to just immediately pull that thing out and change it out with another one. If you're an at-home guy, why not take a chance and at least see if you can't clean it up? I can understand from the shop's point of view not wanting to do that, because you're also starting to assume some degree of liability of a failure to come back. But again, this whole car is all about trying to save a couple bucks where we can. So that's what we're going to do. Alright, so master cylinder is actually in pretty good shape, so we're just going to hone it out. Now I have a special honing kit to do that. Now this isn't something you should expect you're going to be able to just run out there and buy, because this particular kit is from the 1940s. And the nice thing about this particular kit is it chokes down to the sizes that we need for these master cylinders. Sometime after this thing was made is when we decided that master cylinders were somewhat disposable. Problem is it kind of comes full circle. Now some of them are not so disposable. So we have our 22mm honing tool already set up. We're just going to give a little bit cut action in there. I'm going to feed it in. Just clean it up. It's not really rusty in there, but what it is it's got a lot of sedimentation in it. And I don't want to put this thing back together knowing that we could have potentially cleaned it up better than we did. I can already start to see the interior surface being really smooth. So we're probably just going to set the depth on this a little bit more, and that'll be it. Okay, we're going to gauge this out a little bit wider, and that should be it. All right, very minor resistance. We're ready to go. Really clean, we're done. All right, looks like we dodged a bullet and we're able to save a master cylinder. All right, so the entire thing went back together quite nicely, and there's very little grunt to it. So that means that the piston is floating in there quite nicely. Now, before I put this back in, we have to prime this. Okay, and by priming, I'm just gonna put some fluid in there just to get it moving around to confirm that it's working okay. And at that point, I'm putting it right back in. I'm pretty sure we got this problem nicked. We saw that the bypass valve was completely clogged. We saw that the actual cylinder itself had a lot of debris in it. We honed it out, so you know, effectively this should be good to go for many more years. All right, looked like we actually probably saved this master cylinder. I didn't know if we were gonna be able to do it or not because it was becoming a little problematic getting it to bleed. When we bleed the brakes, we don't have a guy normally sitting on the pedal pumping it. We use an evacuation system first, and then we purge it from there with a person on the pedal. We couldn't seem to get the air out of the line, which suggested that the master cylinder was probably stuck. Lo and behold, we got it to work. It seems to be holding fine. We're gonna let it settle overnight. Odds are, because we put this thing through such a traumatic experience, going through all the brakes with the master cylinder and everything else, that there's probably some air still trapped in there somewhere. So we'll let it burp. Once it burps, you know, odds are tomorrow we put it in a quick vacuum, and theoretically that should be it. It should be done. Okay, so while we were working on the brakes, the tires showed up for this. The wheels are at the powder coaters right now, but I was just told they were done, so I will go pick those up in the morning. The tires we're putting on this particular car, because it's super and because the rear end is so tight sometimes to get some tires to fit, we're going to be running a 195/55/15 BF Goodrich Sport Comp 2 series. I'll show you what those look like in a second, but another one of our favorites, which is starting to become a tire that's getting cleared out from what we understand, is the Dunlop Dresdas. I'm going to be running some Dresdas on a 69 I'm building for myself, so we went and got some while we could, but we're also going to be running those Dresdas on a little Spider that you saw the wheels get painted on. It's a good tire, it's a good wet tire, and I guess they decided that they're going to get rid of them. So it's a good buy right now. You can buy them for about 120 bucks a piece, which is a whole lot less than what they were last year. But we're going to be running a 195/60/14 on those, and I'll show you what those look like too. Okay, we're finally at that point where we're really trying to get this Super on the ground and rolling away. This is what I was referring to before. We just got our wheels and tires mounted today. What we did is we took the 15x7 GTA wheels and we had them coated in a different color because that's what the owner wanted. We like it, it's a good choice. And we're actually running a fairly respectable profile on this tire. This particular tire right here, this particular tire is a 195/55/15. And you couldn't put a piece of paper in between the clearance of this tire and the inner fender lip. This is not new. Sometimes this happens, sometimes it doesn't. We do have a limited slipper in. We didn't change the shimming, but the thing of it is the spacing is equally as bad on the other side. So what do you do? It's not a tire issue so much as it is just a general dimension issue. The tires we just showed you, there was a 205/50 over here on a Bridgestone that's even worse. It's much wider. So we kind of ran the narrowest tire that was, reasonable to us. So that's not the problem. The problem is that we're going to have to surface the disc to kind of create some space. We can build a little bit of the face of the disc off. It's not going to affect anything. It's not going to be dangerous, but it'll give us some space for this wheel to drop in. We put these wheels on a lot of cars. Some of them never a problem. Some of them a real problem. And we're running the correct ETs. We're running 35s in the rear and 29s in the front. So this car has the right proportions to it. So this is what we're going to do. We're going to take these wheels off. We're going to take the disc off. We're going to mill the surface of the disc. We're going to countersink where the screws are that hold the disc to the differential, and create some spacing on the back side to kind of drop this in. Effectively, if this was a 35 ET with the milled off surface of the disc, we're probably going to change it closer to a 40 ET in order to create the clearance we need up here. So here we go. Alright, so it's 7 o'clock in the morning. Knowing I had this problem existing, it was a little annoying to me, so I decided to get in here about an hour early, try to make some progress on this. I'm really trying desperately at this point to get this thing not only on the ground, but basically kind of off the books, because this project, as fun as it is also starting to turn into something that nobody really wants it to be at this point. But here's the thing about these Supers when you're running these 15/7 wheels. This area right here from the factory tends to be fairly inconsistent, okay? So we can only feather back so much of this metal before it's pointless, and this is what I'm talking about. We have the factory overlapping right here, okay? This can get cleaned up and there's no reason for it to be there, and it'll help protect the tire from getting gouged, okay? But the inner fender, this section right here, the inner fender right behind it is really, really close. So banging that back is pointless because there isn't anything it's gonna do but bust this up. Okay, so effectively what we really have to do is feather off a little bit of this just simply because it's a little jagged from the factory. The rest of the adjustments have to come from surfacing the front of this rotor. Now there is a fine line in which you don't want to breach. We don't want to make this so thin that it becomes potentially breakable, okay? But we do need to create at least a couple of mils of spacing between this and the wheel. Now, with that said, there's a couple things you will come in problems with on this, okay? So when we surface this, it is always potential that the threads of the lug nuts, if you're using these type, will bottom out. So you're gonna have to cut some of the threads. It sounds a lot like a lot of dramatic work, but it's not that bad. So we cut off a couple of these to know that we'll have clearance on these. Now, there's a couple things we have to do. One, we had to mill off a couple of threads of the lug nut bolts because this will bottom out. Once this is surfaced, the wheel drops in a little bit, the stud becomes a little longer. So you have to cut off some of this in order for this not to bottom out and fully seat the wheel against the rotor. We can't mill it from the back side of the rotor because then that changes the rotor's relationship to the caliper. You can see how dicey this gets. So any thinning out you would have to do to the rotor to create more space has to come from the front. Again, we only need a couple mils. It's 7 o'clock in the morning and I'm not thinking terribly clearly anyway. So to the lathe we go. Okay, so basically the surface of our rotor is about 10 mils thick. I'm not going to tell you a number in which I'm comfortable with milling this off because what I don't want to happen is somebody going out there with a die grinder or something, cutting down these discs, trying to justify the thinness of it, and then fussing at me if this thing breaks loose on it. I'm going to mill off a certain amount of this. I'm not going to cross a certain line of how much I'm willing to mill off of this, and that's going to be it. Effectively, again, if I cut off a mil or two from here, for example, if that's all I was going to cut, I will pick up a mil or two of the wheel clearance to the inner arch on the car. So we're gonna get started, and there's a lot that has to happen here though. Not only do I have to take the surface off of here, but I'm gonna have to also recreate the countersink from the screws that hold the rotor to the actual hub of the rear end. So we're gonna get started. Take a little bit off at a time. I'll take several passes over this to effectively create what it is I'm trying to create, and then we'll put it on the car. I may potentially end up putting this on the car 2 or 3 times before I finally get it fixed that I'm happy with. But after this is cut, the next thing we got to do is we got to go ahead and create a little more lip clearance on the overlapping, factory overlapping on the car. And again, if my language is a little jargoned up, excuse me, it's 7:09 in the morning. Things we do to make these tires fit. Okay, so we milled off as much as the actual lip as I'm going to mill off. It is no longer becoming a part of the tires issue. The tires issue is actually coming from this in-step relationship to the inner fender. We can't just bang back the inner fender because it's right against this wall, and I'm about to show you how close it is. What we're going to do is we're going to measure outside wall to outside wall. When you figure there's probably a little bit of dirt and debris on the inside of the fender well, and you got a lot of paint and primers and stuff on here. When you subtract those additional mils of material from the metal to metal relationship, that is how wide the inner wall to outer wall relationship is. That's why I cannot bang back that inner wall. There isn't enough there for me to work with. I can't get my finger through there to give you an idea how close that is. So we milled off a lot of the face of this. I still have more room to go. But we're just going to mill off a little more. I mean, it clears right now. The thing that's going to happen is even with the low profile tire, when you turn aggressively in and out, that wall profile changes. It goes in and out. When that wall profile, in this case, because we're on the right side of the car, when you're making a heavy right turn, that tire flexes to the outside. It flexes outside, it's going to rub that inner fender. So basically all this effort is we're trying to minimize the potential of that happening. I can't shim the differential, which is normally what you would do. You would shim the differential to kind of shift it over one way or another, because I had the same problem on the other side. It's just as bad on the other side. These things become a little more pronounced when a car's been rear-ended, because rarely does a rear end actually go back into place by a body shop exactly where it was. Not to mention, these things aren't exactly all that square from the factory on the rear end in relationship to the inner fender. So it's a lot of trial and error, but this car will be on the ground today. Alright, so we milled as much as we're going to mill off of the surface of the disc. We've put a special chassis primer on what we've grinded off of the back sides of the lip. In fact, we have done all we can do to create the wheel clearance that we need. The car kind of sits down pretty low in the back, so we're most likely going to shim it up a little bit because it's a little too low in the rear. But effectively, this side is done. Now we got to start the process all over again on the other side with the other disc. But it looks like it's going to work out. Well, when it rains, it pours. What can you say? Now that we got the thing actually in good running order, and we got the tires and wheels on, and well, now there's a couple things we come to the conclusion. We need to get the rear end of the car up a little bit. We've narrowed the rotors as far as we're willing to do. We made sure that the shimming of the differential is, equal on each side, so we've done all we can do. But effectively, it's still a little too close in the rear. So what we're going to do is we're going to put some billet aluminum shims in to kind of get the rear end up a little bit. That's okay because it kind of sat a little too low anyhow. But our next challenge is this. Now that we got a good working master cylinder and our brakes are in good working order, once we fired up the motor, the brakes locked up. That is generally a telltale sign that the vacuum that the booster is pulling is usually literally pulling fluid right out of it, and when it does that, it's pulling that fluid in the sense that it's making the brake master lock the brakes up. Okay, so that's just an indicator that the booster needs to be changed out. So I'm going to try to use a used one we have, because as you all know by now, I'm sure, brake master cylinders are not that cheap, but more importantly, the boosters are really expensive. So, first things first, we're going to pull this one out. I'm going to crack it open just to see if we can determine what it is that's causing the problem. But we're not going to fix it. We're just going to swap it out with the one we have. Now, I don't throw these away. What I typically do is I send these out and get these rebuilt as well. The parts that are used on the rebuilds are pretty doggone good. These original Bonaldi masters or brake masters are really nice. So, they rebuild very well. And it tends to be a little cheaper. Now, it gets more expensive if I were to send the vacuum cylinder out to get gold CAD coating on it. So there's always that line which you don't want to cross. But effectively, that's what we're going to do. So right now, what I'm going to do is I'm going to start tearing this thing out and see where our problems are at. Okay, so we have a replacement booster used, but we know it's in good shape. It came from a perfectly good running situation that we're going to drop in for this one. One of the things I want to show you. Okay, so here's where we're at. We've taken the brake line off the front of the booster, and I put a rubber line on it, which you can see right here. This line's higher than the reservoir, so I don't have to worry about fluid somehow magically coming up out of the top of this and dripping all over our engine bay and ruining our engine bay paint job. Now I got to take the back one off. Okay, so at this point, you back out the line, get it loose, and then you separate the master cylinder, I mean the booster, from everything. At that point, you should be able to peel this away, and then take another rubber line and put it on that one, and have the two sit here by themselves, as to not drip fluid all over the engine bay. Okay, so I'll show you how that works. And that nasty booger's out. And then we take our rubber line and put it on there. Tuck it up with the other one. Now I don't have to worry about brake fluid ruining my paint job. Okay, with that one removed, now what we're going to do is we're going to separate it, and we're just going to take a preliminary inspection of it and see what it is that was actually creating the problem. Again, the situation was the brakes work fine. The minute you started the car up though, and the booster became a part of the braking system, the vacuum caused from the motor to the booster made the brakes lock up, and it was just absolutely unmovable. It kind of sucks because we were this close to being done with being able to get this car moving along on its own, and now we have a little hiccup like this to do. What you saw should never ever happen. What that was a tremendous amount of fluid that was actually in the booster. So when we separated it, the booster rubber packing itself was in good shape, so that wasn't the problem. What the problem actually was is that the seal in the actual master portion of the booster agent is blown out. So it's pumping all the fluid through here. So the minute the motor goes into vacuum, that seal being blown on the inside of this, it's just literally sucking the fluid right out of it. And it's just putting it into here, which is creating as a storage cylinder. Okay, so that's technically good news. It means I don't have to do a whole lot of figuring out what caused all this. All right, so we're putting our replacement donor brake booster in place. Again, this can actually kind of create a whole lot of havoc if you're not really aware of what's going on. If the booster slave cylinder starts to leak, and it pulls it into here, theoretically it could potentially end back up into the engine. Granted, there's a few other things that need to fail for that to happen, but it does happen. Case in point, this is our vacuum line that was coming off of it. It had brake fluid in it. Typically you can see something like an oddly smoking motor, for example, could show up. All sorts of weird things can happen, but effectively in our case, our biggest problem was as soon as you started the car up, the brakes locked up. Now, the only thing I have left to do is put this vacuum line on, and I need to reconnect the front portion of the slave cylinder and bolt it back down. But you can buy rebuild kits for these. They're not terribly complicated to work on, but completely restored ones or new ones are very expensive. So don't be afraid to tackle this. This is a very serviceable part, and it doesn't take a whole lot of ingenuity to do the work yourself. And there are a couple of Alfa Romeo parts suppliers online who carry all the parts you need to completely restore this thing. So again, we're going to reconnect the front of the slave cylinder, we'll put the vacuum line on, finish bolting it down in place, and theoretically this thing should actually quit locking up when I start the motor. Okay, A, you should never ever see any kind of fluid coming out of the actual booster itself, and that's, you've got to be kidding me. And I got a phone propping this thing up. Anyway.
Okay. Jesus is lit. See, I can't even say one sentence anymore.
What?
Jesus is my homeboy.